An important but potentially complex part of Chapter 12, which is mixtures, is dealing with atmospheric air. We all have experience with dealing with atmospheric air. And so I've created a number of videos to illustrate the most important parts and some problem solving tips for working with atmospheric air. And so this part of chapter 12 could be one of the most important parts of chapter 12 because we encounter atmospheric air so frequently in our lives, throughout our lives, and in many cases throughout our engineering practice. Now, what I'm doing here in this module is I'm trying to illustrate to you that you need to jump over to a different playlist in order to access this set of 4 videos. And I'm going to step you through sort of an idea of each one, but recognize that a different playlist called Example Problems Psychrometrics, and that's a synonym for dealing with atmospheric air. That's where this set of 4 videos is available. So I'd like to step you through basically what the content of each video is, but I didn't want to go through the drill of creating brand new videos to post over into my chapter key points. So please do be aware that it's a little different playlist to access these atmospheric air videos, but they are summaries of what's covered in chapter 12. And so the first video over in this different playlist, Example Problems Psychrometrics, is Atmospheric Air video number 1. And so a quick look at what is atmospheric air all about, especially to an engineer. So you know good and well from your life's experience that our atmospheric air is made up of dry air. Well, of course, that's that nitrogen, oxygen, ideal gas mixture, but also mixed into atmospheric air is water vapor, isn't it? Just as illustrated by this excellent screenshot. So, you know good and well that we've got ideal gases. And it does turn out that the partial pressure of the water vapor is so low in the air, partial pressure of the water vapor is so low that we're going to treat H2O in the atmospheric air as an ideal gas. We're going to treat it as an ideal gas until it starts raining. And then you've got liquid water. That's saturated liquid water when it's raining. So that's a little different animal that's covered in these videos, but do recognize that atmospheric air is a very special type of mixture, which we're going to say it's dry air and water vapor that's behaving like an ideal gas when it's in this atmospheric air mixture. When it rains, a little different animal. That's water. In Atmosphere 01 video, which runs 27 minutes, I introduce you to 4 key components of dealing with psychrometrics. That's a synonym for atmospheric air. Partial pressure, had a little bit before on that. Humidity ratio, now that's a definition. Well, you're going to need to watch the video to see what the definition of humidity ratio is. Introduce the idea of relative humidity. Now, anybody that's watched a weather report on television is pretty aware what relative humidity is all about. It's reported all the time. And you know what happens when the relative humidity reaches about 100%. That's when it rains. Similarly, dew point. You may have heard in your experience the idea of a dew point. When does the dew form on the grass in the early morning when it's chilly? When does the dew form on the grass? That's called the dew point temperature, and that's a real honest-to-goodness engineering property. So you'll learn more about how to calculate the dew point temperature for atmospheric air through these videos and through Chapter 12. Atmos Air O2. So that has to do with defining. It's an entire video that runs 13 minutes where I define the dew point temperature. And how do you, as an engineer, how do you calculate what is the dew point temperature? If you're given the relative humidity, can you calculate the temperature at which the dew is going to form on the grass? Kind of like this image, dew is formed on the golf course fairway leading up to the green here. Dew point temperature. Part 3 has to do with heating of a whole house. This is a little bit of a cutaway view of a whole house forced heat furnace in which we're adding heat to the air that's coming back from the room. It's cooled off, but we need warmer air in the wintertime to heat our house. So we're going to supply a warm air supply back to the room. This is a classic example of a psychrometric engineering problem. Some engineers have spent entire careers on heating, ventilating, and air conditioning and have done very well for themselves financially. So this part 3 has to do with the winter heating situation, heating of a whole house or a whole office building or a whole industrial space. Even more complex is part 4, Atmos Air 04, which has to do with cooling your house or office space or industrial space in the summer. Air conditioning, cooling. Now, that's a little more complex because you see, when you cool the air with refrigerant, you're going to cool that air down below the dew point, and you're going to have a drip, drip, drip from your condensate pan in your HVAC unit, and it's going to go to the drain. It's going to be cold water going to the drain. Water's being pulled out because of the cooling process. Water's being pulled out of the summer air and then provided back to the room in a much colder situation. But condensate is pulled out of the humid air in the summer. That's Atmos Air 04. And as a reminder, go to Example Problems playlist, Example Problems, Psychrometrics, and that's where you'll find this set of 4 videos for psychrometric fundamentals and calculations. Also in this playlist, I'm offering you 3 start to finish worked out example problems associated that are taken from the Chapter 12 textbook problems. And in fact, I show you how to use the psychrometric chart in these example problems. And if you're assigned, if your instructor wants you to learn how to use the psychrometric chart to determine atmospheric air properties, these example problems are really going to help you out. So you can find them in Example Problems, Psychrometrics. So that's an overview of the kind of video material I offer you for the end of Chapter 12, working with atmospheric air. Can be a difficult topic to master, but it's worth the effort because it can really pay off if you have interest in heating, ventilating, and air conditioning as a career opportunity. Hope that helps, and hope you get some value out of these videos. And we'll see you next time on more videos.